So I'm gonna do only part C of number one. Making a slope field shouldn't be too bad. Maybe with part B, it's just interpreting what they're asking. It's asking you with a whole bunch of complicated words. When is the slope positive? Well, two ways I can tell that. One, I can look at my graph and say anywhere above y equals 1. Two, the slope is dy dx. So what makes this expression positive? Well, x doesn't matter at all because x is going to be positive, or x squared is going to make that piece positive no matter what. For the y, well, if y is greater than 1, then this term is positive, which makes this whole product positive. So that's why the slope is positive whenever y is greater than 1. So that's the answer for B. I guess I just lied to you a moment ago. I kind of did go over B. Anyway, for C, I want to solve this. It's basically an initial value problem. I want to integrate, get my plus C, and then use that f of 0. They call it f of 0 equals 3, but that's the same as saying y of 0 equals 3. So, you should recognize, especially since we've been working them recently, that this is a separation of variables problem. So I'm going to divide by that and multiply by that. So what I get is dy over y minus 1 equals x squared dx. So now it's in an integratable form, so I'm going to integrate. When I integrate the left side, I get y minus 1 ln absolute value of that, equals 1/3 x cubed plus c. So in order to get rid of both, or to, can I move over? I can. In order to get rid of the ln, I do e to the on both sides. So when I do e to the, it cancels on the left and gives me just straight up y minus 1 equals e to the 1/3 x cubed. I could write the plus c there, but what I'm going to do is move it out front using exponent rules that we've talked about a whole bunch. And it's not the same number. If I were to solve for the c in the previous line, it might be like 20. And here it might be like, I don't know, it would wind up being e to 20, so it would be some other huge number. So they're different c's, so that's why I put the c1 up here. So we bring it up here, and now I'm going to incorporate this thing to solve for my c. So I know that y is 3 minus 1 equals c times e to the 1/3 times 0 cubed. So all I did was I plugged in 0 for x and 3 for y. And I'm using that to solve for c. So I get 2 equals c times e to the 0. Well, e to the 0 is just 1. Anything to the 0 is 1. Well, mostly. So I get c equals 2. Right? And then I just need to kind of write my final answer here. I need to combine that solving of c with this equation. So my answer, and I'll move, you know what, I'll move the 1 over at the same time. So I get y equals 1 plus, my c value is 2, e to the 1/3 x cubed. And that is all for that one.